Welcome back to our channel. Question 5 is about apparent weight due to the rotation of the planet. Okay, it said that there is a mass here on an unknown planet. It is rotating, so it must have a net centripetal force towards the center, right? So where does it come from? Okay, so it asks you to think about the free body diagram of the probe. Okay, it is on the surface, so there is a normal reaction force acting on it, and there is a gravitational force acting on it, and these two forces act together becomes the centripetal force. So the equation is centripetal force equals Fg minus N. Why Fg minus N? Because centripetal force is towards the center, Fc is along it, and N is against it. So we change it. Okay, so normal reaction force equals Fg minus Fc. So Fg is a gmm over r squared. Use the terminology capital eta R. And centripetal force V or omega. Yeah. Omega. Okay. So minus m omega square r. Take out the m and you got this relationship. Well done. It is a song question. Remember, don't jump too many steps. Okay. Next one, the details that the probe will remain on the asteroid surface only if omega, yeah, some constraint. Look at here. What is the constraint? The constraint is n. N must be larger than or equal to 0. So you write down the constraint. Probably you get 1 mark already. This is the constraint. So the constraint will be that string. Okay, so copy it. M gm over r square equal omega square r. It must be larger than or equal to 0. Move omega square r to the right hand side, so gm over r square is larger than or equals to omega square r. Okay, omega square on one side, excellent. And move the r to the other side and then swap it. Okay, this is smaller than or equal to gm over r cube. Take square root of both sizes. We got it. Well done. Next part is another question that really has no relationship with A and B. I'm sorry. Remember, A, B, C can be no relationship. 1, 2 must be related. Okay, number 1, they said that another probe orbits the sun, but it is 4 times the sun. Change first, okay? 4 times distance between the Earth and the sun, so that the intensity of the solar radiation on the probe is 85. So first of all, you have to remember this kind of intensity drops with 1 over r squared, right? So now it is 4 times, so 1 over 4 square, less than the solar radiation on the Earth. But what is the solar radiation on the Earth? You need to remember the term. Solar constant. Yes, that's the solar constant. So the intensity on the probe is the solar constant. Look it up from the data bullet. Do you have the data bullet? Yeah, you got it. It is 1.36 times 10 to the power 3. So 1 over r square, 1 over 4 square. Calculation time. You got it. Well done. 85, right? 85 watt per meter square. Excellent. Next one. Estimate the equilibrium temperature of the probe, assuming it behaves as a black body. Black body. Copy the equation for black body. I equals sigma T4, right? Ideal black body. So this is the emission intensity. So these two should be the same in equilibrium, right? The absorbing and the emitting radiation should be the same. So I know our sigma T4 equals 85. So sigma equal IR, copy it from data book again. Okay, 5.667 times 10 to the power negative 8. Okay, so calculation time again. Got it? Just checking. Okay, so the temperature should be 197 Kelvin. Well done. Did you get it? Sure, you get it. Okay. So we finished question 5. Well then, see you on next question. Bye bye.